Now, Kirchhoff's laws told us in a series circuit, the current was the same everywhere, and the resistance and voltage summed up. So the total resistance was higher than any of the individual resistances, and that makes sense to us. However, in a parallel circuit, the voltage is the same everywhere. So if you have a 9-volt battery, then every single resistor or light bulb gets the exact same 9 volts. That's why in a parallel circuit, every light will be the same brightness. And that's why parallel circuits are more preferred, along with other reasons. However, the resistance is actually less than the resistance of any individual resistor. Adding more resistors makes the equivalent resistance less because of the way we calculate it. So if we look at this problem, we've got 3 resistors connected in parallel with a 75-volt battery. So resistor A is 50 ohms. Resistor B is 30. And resistor C is 10. And the voltage is 75 volts. And remember, in a parallel circuit, the source is 75, the voltage drop at C is 75, at B is 75. It's the same everywhere. So we're asked to find the current through each resistor. Ohm's law tells us that R equals V over I, and thus that I equals V over R. And if we're talking about each resistor, then we're going to use individual resistances here. So for A, I equals V divided by 50. And so our current is 1.50 amps. So we have to have 3 significant figures. And for B, we have 75 divided by 30. So we have 2.50 amps. And for C, we have 75 divided by 10. And so we have 7.50 amps. And you can see that as the resistance increases, that the current decreases, which makes sense if the voltage is consistent. And now we're asked to find the equivalent resistance of the circuit. Now we know that equation is 1 over the equivalent resistance equals 1 over the resistance of A plus 1 over the resistance of B plus 1 over the resistance of C. And the math here is going to mess you up more than anywhere else in this entire chapter, I believe. So when we add this up, and what I do is I just put it in straight like this with parentheses around it. And so I get 1 over the equivalent resistance equals 0.1533 repeating on. Just so you don't have to write this answer down. Usually I'm just writing it down so you can check where you are. Now in order to get equivalent resistance, not 1 over the equivalent resistance, because I definitely don't want that. This is not the answer here. You are going to look for in your calculator a button that looks like maybe this. Maybe it looks like 1 over x. Or maybe x to the negative 1. And if you don't have either of those, you will literally put in caret negative 1. Because negative 1 is the same thing as underneath here. So you can use any of those buttons, and if you can't find them, please send me a message and I'll help you find them. And you get the equivalent resistance here with 3 significant figures is 6.52 ohms. And you can see that's smaller than any of these individual resistances. So the equivalent resistance is less than any individual resistance in here. Finally, you're also asked to find the current through the battery, the entire circuit. We're still going to use Ohm's law right here, but we're going to use the total resistance. So I equals V over R. So it equals our voltage, and that's the same everywhere, over our total resistance to get our total current. And you can see that it is 11.5 amps. Now you can also find this current by summing up all the individual currents. Because remember, in a series circuit you could do that with the voltage. Well, in a parallel circuit you can do that with the current. So if you add all these up, you still get 11.5 amps. So either way you find that answer is fine. Please try some of the practice problems just to make sure that you're comfortable with the math. Again, none of this math is hard. It's just making sure that you understand what to use when and keeping it all straight in your head.